Hello, so this is the first of two recordings looking at statistics, and this begins with some basic principles, and then the second recording will actually focus on some of the specific statistical tests that we teach and you might find useful in your data analysis. So as you can see from the plan, this is what I'm going to go through here, so it's actually just to give you some of the background ideas to doing statistical analysis. So first of all, I want to talk about describing data. Now, describing data is very important, and you will need to do this with your quantitative data in your dissertations. So basically, we can divide statistics into two types, descriptive and inferential. Now, the descriptive statistics basically just sort of trying to describe the numbers and the relationships between them. And we often want to do this at the start of our results sections, just to sort of set out some of the basic patterns in the data. So we want to know, for instance, the percentage of men and women who've completed a questionnaire, what age group categories they fall into and how many fall into these different age group categories. We might want to know some basic data about their motivations, if that's what you're collecting data on, so the percentage of people who align with this motivation and the percentage of people who align with that motivation. Okay, so we always want to start off with this before we actually go into the inferential statistics. Now, the inferential statistics, this is about analysing numbers and drawing conclusions from them to make guesses about the wider population. So remember, you're using a sample, and what we're trying to do is draw conclusions from that sample, and that's what inferential statistics are about. So, first thing we might do is use some proportions. In SPSS, these are called frequencies. So the frequency and percentage of men and women attend at the event. Okay, so here in that example, you can see the men and women, the frequency is the number, there's 26 men, 41 women, and then we can put that into percentage terms. So 38.8% were men, 61.2% women. It's quite helpful to sort of present this data at the start about our respondents, but we'll also want to present this kind of data about most of the questions that they've answered. So it's important that you understand how to do this in SPSS in a quantitative dissertation. We can also present that kind of data in various graphs. So I've got a pie chart here. I'm not a big fan of pie charts, and in fact my guidance has always been that you should only use pie charts if you've got 6 or less categories, because they become hard to interpret. But I've got some data here in a pie chart, which is proportion of residents and non-residents visiting the beach, and there's 4 different groups there. I've also got that data in a bar chart, and you can see straight away the bar chart is much easier to read, which is why I deter students from using pie charts. So you can see straight away that the largest group is the people staying 1 night or more. Okay, so think about how you're presenting a data set. It's visually easy for people to interpret. So that's a good way of describing some of your data. We can also use things like the mean. Now, you probably remember back in your school maths, you covered concepts like mean, median or mode, and some of you might remember what they mean. If you don't, just go and look them up. If you've got ordinal or scale data, using the mean can be very useful. Technically, we shouldn't present the mean of ordinal data, but actually I think it's quite useful to do so. And there are different schools of thought about that, so I wouldn't worry about it. I quite often use means and report means when I have ordinal data. You cannot report means when you have nominal data, because that's just data in categories. You can't work out the mean of whether people travel by car, bus, train or cycle. Okay, it doesn't make any sense. But you can calculate the mean when you've got a scale from strongly agree to strongly disagree. Okay, and if that mean comes out at around 2 and you've coded strongly agree 1, agree 2, you know that people are more towards the agreement end of that scale. So I've got an example here of satisfaction scores that people have scored out of 10 for 2 sports events. And this is just to flag, really, that when we calculate the means, we also want to report something called the standard deviation. So in event 1, you can see the scores that people have given there. They're 5s and 6s, and the mean comes out as 5.5. So event 2, actually the mean is the same. It's still 5.5, but you can see the answer options are really diverse. Someone scored it 1, they really weren't satisfied, and someone scored it 10, they were very satisfied. But it's quite varied. And this is why we report the standard deviation. If you see the standard deviation for these, you can see it's very different. So for event 1, the standard deviation is very small, okay, 0.53. Therefore we know that the data is very closely clustered around that mean score of 5.5. Whereas for event 2, the standard deviation is much bigger, it's 3.17, and therefore we know the data is very spread out. So it's useful to report that when you're reporting means. Another thing we want to do with descriptive statistics is examine relationships and differences. You know, we can do that. One simple way of doing that is with something called a cross-tabulation. This is particularly useful where you've got nominal data, and it can also be used with ordinal data. We wouldn't normally do this with interval ratio data because we have too many lots. There's lots of different categories, so it doesn't really work. So, you know, I've got an example there. You might want to know if men and women's motivations for attending an event are different. You might want to look at income and attending event. Okay, and then you can use a cross-tabulation. And I've got a little word of warning there to think about this at the design stage because it does have implications for sample size. So going back to a session I did on quantitative sampling, you know, sometimes you can actually work out that you need so many people in your study because of the analysis you want to do, and I'll just illustrate that. So here's an example where we're looking at people's gender and the type of event they've attended. So there's 4 events there, and I've compared men and women. Okay, and I've got the number, and then I've got, you know, the percentage. So at the rock concert, I've got the percentage who are men, percentage who are women. Okay, so in that case, I've got slightly higher percentage of men attending the rock concert compared to women. This is a little bit stereotypical, I think, this data. You know, the outdoor theatre, I've gone with more women attending. Okay, so 76% of women attend that compared to 23% of men. So, you know, we can usefully pick up patterns using this cross-tabulation without doing, you know, any inferential statistics. Now, issues in terms of sampling size. So I've got something here where I've looked at age and whether they plan to attend an event or not. So attend the event or do not attend the event. And I've got a sample of 50. Now what you can begin to see here with just 4 age categories, that data begins to be fairly sparsely populated across all those different options. And in fact, in one of those, under the age 25 to 34, only one person falls in the category of not attending the event. And one of the problems here is you know, once you've got, if you've got, say you had 4 age categories and then you had 4 categories in your down the left-hand side, that data becomes very spread out and it becomes very hard to see patterns very easily, unless there's a really obvious strong pattern. So, you know, this is where, you know, samples need to be fairly large. So 50 people might be great for certain kinds of statistics, you might get away with that, but actually when you start doing things like a cross-tabulation, you know, you can't pick up the patterns quite so easily because it becomes too spread out amongst the different answer options. So think about how many categories you have in the questions you want to compare. Okay, so a word about theory and hypothesis testing. I don't use hypotheses in the research I do because I tend to do quite inductive quantitative research, which is perhaps a little bit unusual. So I use research questions. So I do say to students, don't get bogged down in trying to work out hypotheses. If you have a clear research question that relates 2 variables together, that's probably all you need to have. But basically the idea behind this is theory is a set of principles that explain known findings about a topic and from which new hypotheses can be generated. So in your literature review, you might have identified some theory that you want to, you know, use in your study, and you've used that to create questions in your questionnaire. And obviously that theory might specify that, say something like age links to social media use of some description. So you've got a question that asks people about their age, and then you've got some questions about social media use, and you're going to hypothesize some relationship between, you know, those age groups and their use of social media. So it's a prediction about the state of the world. We have 2 types of hypotheses. We have the alternative hypothesis and the null hypothesis. Now the alternative hypothesis is a prediction that there will be an effect. So, you could predict that younger people use social media more, for instance. Whereas the null hypothesis is the reverse of that hypothesis, which is that the prediction is wrong and the predicted effect doesn't exist. So that would be that there is no age effect related to social media use. So some examples here. The null hypothesis, there's no difference between men and women's satisfaction with the beach. And the alternative hypothesis, there is a difference between men and women's satisfaction with the beach. Now, although you're probably setting out to test your alternative hypothesis, that there is a difference, actually statistical tests test the null hypothesis, the first of those. They test that there's no difference. And if there's only a very slim chance of there being no difference, then you reject the null hypothesis and accept the alternative hypothesis. So, well, I've just said that, sorry. So that basically says that. So statistics tests focus on the null hypothesis rather than the alternative hypothesis, and therefore, we make the decision on the basis of rejecting that. So one of the things we do when we're looking at statistical significance is it's basically underlined by the ideal of probability. And again, probably when you were back at school, you'd have done probability in maths and you'd have worked out how to calculate this. And it underpins statistical analysis. So, we use it to aid decision making, estimate errors and test hypotheses. And it's important you've got some understanding of this, because if you're doing a quantitative study, inferential statistics, ideally need to be used to get you the higher marks, and therefore you need to have a little bit of a grasp of this, well, quite a good grasp of this really. So probability always falls in the range from 0 to 1, and 0 is that it's impossible for something to happen, and 1 is it's absolutely certain for something to happen. So if you have a probability value of 0.95, that's very close to 1, and there's a very high probability of something happening. Whereas a value of 0.05, it's not very likely to happen. There's a low probability of something happening. And actually that 0.05 is quite important in statistics, because that's the threshold level that we typically use in statistical tests to work out that there is a low probability of something happening. So what does a statistical test tell you? It tests the pattern in your data. So for example, whether a difference between two groups, so you might be looking at men and women and whether they're going to attend a rock concert. And, you want to have a look and see whether there's actually a difference between those two groups and whether that could have occurred by chance. Now, basically, it tests the null hypothesis, so that basically it tests the hypothesis that there's no difference between men and women and their likelihood of attending an event. And if this is found to be the case, less frequently than 5% of the time, i.e. it's less than a probability level of less than 0.05, then we would normally reject the null hypothesis. Okay, so when you do statistical tests, you will see there is sometimes referred to as a significance value in that test result, or sometimes it's written as a p-value. Okay, and we look for that to be very small. If that's very small, we reject the null hypothesis, and we can accept that there is a real pattern in the data that we found. Okay, so one thing you need to be careful about is statistically significant. Significant means something special in quantitative data analysis, so be careful how you use it when you write up. Don't just talk about this is very significant. Actually, significant has this special meaning here. And what we're going to do is use this 5% level, and this is the probability of 0.05 or less chance of something happening. Okay, and you often see it written as a p-value, and frequently, as you can see in brackets at the end there, p is less than 0.05 using that little arrow symbol. So my guess is, unless you've done statistics before, you'll probably be feeling a bit lost at the moment, so you're going to need to do some reading around the topic. So the Saunders book, chapter 12, which is available online as an ebook, I think that's a good place to start. Also have a read of the data analysis worksheets I've put on Brightspace, and make sure you attend SPSS workshops if you're doing quantitative research in your dissertation.